Okay, let's take a look at the Siemens IO connections on our trainers. So this is very similar to what we were doing with the SLIC 500s. We have sunk inputs and sourced outputs. So, and they're AC. So what I'm going to do right here is I'm going to take the neutral and I'm going to run it to the white. Now, when you look at the PLC, you notice that it says that it has DC inputs on the PLC. Well, what we've done is we've ran everything through a relay. So basically what our inputs are doing are turning on a relay, and the relay is switching the signal. So when you push the button, you hear the PLC click, and that's relays, interposing relays on the back side of the unit that we're using to basically switch on the DC when we have an AC circuit. But for the way that this is wired, we would need to sync it to neutral, and we would need to run voltage up here to 1L. Okay. Now, because this is per module, so it looks like 1L has 1, 2, 3, 4, 5 outputs associated with it. Okay. And then 2L has 1, 2, 3, 4, 5 outputs associated with it. So we have to tap the second voltage here if we want to be able to use these outputs. So if we're doing the I/O connections for two solenoids, I guess I can throw the solenoids here. One SOL, two SOL, two motor starters, one MS, two MS, and that would be our outputs. So even though we have powered up this bank of these second ones here, looks like we're only using 4. We could have connected them down here. And remember, the outputs are Q, and they go, it's 8, so 1, 2, 3, 4, 5, 6, 7, 8, so up to dot 7, and then they switch to 1, so 1.0, 1.2, and if we had a different unit with more I/O, it would be 1.3 all the way up to 1.7, and then it would start over. But the way that this is, so it's a little bit confusing like that, especially since the first 8 from 0 to 7 here are not all on the same voltage tap. We have that second 2L voltage tap for these 3, and then 2 of the next address Q1. But that's the way that it is. So these need a common because we have voltage here. These then need to get brought back to the neutral so that we have a current loop from plus to minus. Now we're going to hook up, wanted 2 start push buttons. So it looks like, I'll put them right here. 1 PB, 2 PB, a stop push button, we'll put 1 closed, 3 PB, and you could label these start, stop, etc. A 3 position selector switch. So what we're going to do is we're going to run it into 2 separate inputs, because the 3rd position would be not engaged, but it could be selected to this input or this input. So that's where we're at with that. So we'll do 1 SS, a 2-wire prox, so we'll throw a prox in there. Okay, and a photo switch. So I'm just going to throw that down here. It says 2 wire, so we'll put that on here, a photo switch. And so it looks pretty good. Basically then is we need to take our commons here, because they were sunk, this needs to go back to voltage. And so once again, the addressing scheme is 0.0 all the way up to 0.7, working in 8 bits here. And then you start on the next round of 1.0, 1.2, and up to 1.5, because that's how many inputs we have. If we had more, it would keep going up to 1.6, 1.7, then it would start over on the next one. So that's a quick review of the Siemens IO connections.